Hey everybody, it's Mr. Carr again. Today we're going to be looking at 8.4. We're going to find we're basically going to be looking for using a coordinate plane. We want to calculate the perimeter and area of a figure. So when we do this, we're going to look at a few things that are helpful in terms of their properties. So for example, understanding with a parallelogram. In a parallelogram, the sides, we have two pairs of sides that are the same, but they're also going to be parallel. Okay. So we got parallel here and here. So that's important. Okay. With a rhombus, all four sides are congruent. So it's four congruent sides that's going to be important on a coordinate grid. With a rectangle, the sides we have basically, usually with a rectangle, we have something like this. So not only are they parallel, but they're going to be, the sides are perpendicular to each other. Okay. Finally, with a square, remember that's a rectangle and a rhombus. So we have four congruent sides, and they're all perpendicular to each other. Oops. Now, in terms of angles, like I would say the only thing that might show up again is kind of like the perpendicular idea. We have right angles here and here. Okay. It's a little bit tougher with parallelograms or rhombus, especially on a coordinate grid. We don't necessarily have those exact values. We're not going to really look for those on there. If we look at a trapezoid and a kite, so some other things that we didn't quite cover on that one. Sides, we have exactly one pair of parallel sides. Okay, so parallel sides means on a coordinate grid, we can kind of analyze that a little bit there. With a kite, we have two pairs, whoops, of congruent sides, but opposite sides are not congruent. Okay, I'm going to add that on there. So when I look at opposite, like right here, these are not going to be congruent to each other, just like these are not congruent to each other here. So if I go look at opposite sides, they are not going to be congruent there. But I do have two pairs of consecutive sides in a way. So this one is congruent to that one, and then this one's congruent to that one. So just make sure to kind of specify that. In terms of angles, there's not really much to say about that one. I'm not going to worry about that one as much. Okay. Quick review. When we do this on a coordinate grid, we're going to have to use our area formulas a lot of the times. So parallelogram, rectangle, square, all of those are base times height. Okay. Triangle is going to be 1/2 base times height. Rhombus, kite, and square, that is all going to be areas 1/2 of diagonal 1 times diagonal 2. So notice that if we have a square here and a square here, it just depends on how it looks on a coordinate grid. So if you can see what's the height and what's the width, the base of the square, do that easily. But if the square is kind of rotated a little bit, then I would look for diagonals at that point. Then we got trapezoid. Trapezoid is going to be 1/2 of base 1 plus base 2 times the height. Okay. So let's look at some examples of this. Draw and classify the polygon with the given vertices. Find the perimeter and area. So we got F is at 2, 8. So we got F is up here. G is at 4, 4. H is at 2, 0. So we only have 3 points. Classifying is very easy. This is going to be a triangle. Okay. So that one's really straightforward. But now I want to find the perimeter and area. Perimeter is always going to be the distance around the shape. Well, because of the key word there, which is distance, I'm going to find all of my distances, meaning I'll start with the easy one. Like if I look at this side here, I just count up the spaces. It's a vertical line, that's easy. Okay, so that's going up from 0 to 8. So I'm going to say that FH is equal to 8. FG is not on that straight line, or it is a straight line. It's not on a vertical or horizontal line. But I can do this. If I want to find the distance between points F and G, I can model it using a right triangle now. This is 2, and this is 1, 2, 3, 4. So I can do Pythagorean theorem with that. So I'm going to call that x for right now. So I'm going to go x squared is equal to 2 squared plus 4 squared. So that's going to be 4 plus 16, which is going to give me 20. And then I square root that. So I take the square root of 20, and that comes out to about 4.47. Now, if I look at the other length, the GH there, so that is, what was that? That's FG is equal to 4.47. Well, that's going to be the same as GH, because if I do that same idea, that's 1, 2, and then 1, 2, 3, 4. So that's also going to be GH as well. Oops. GH is also equal to 4.47. So that means my perimeter is going to be the sum of all three of those. I'm just going to add up 8 plus 4.47 plus 4.47. Okay, so I do that. And I get a total of 16.94. It's on a corner grid, so we're just going to say units. Okay, now area. Key on this one is once we classify the shape, we know that we're going to use 1/2 base times height. So the thing with triangles is base and height can be different. Technically speaking, I could call this the base, but then the height is difficult because the height would have to be perpendicular like this. Okay, so my triangle height would be outside that triangle there. But let's pick easy numbers. For example, this can be my base and height. The only important thing is that they're perpendicular to each other. And so with this kind of a triangle, those are going to be my base and heights. So when I do that here, my base is equal to 8 and my height's equal to 2. So I can just plug those in my formula now. So 1/2 of 8 times 2. So that comes out to 8 units squared. Okay, so that's for the most part, we're going to do a lot of those types of problems. The next one is going to be, I think, a little bit different. So let's try that one out. We got 3, 5 is right here. So that's L. M is at 6, 8. N is at 9, 6. O is at 5, 0. So you look at this one, it almost looks like our kite shape. The problem is it's not. It is a weird polygon here. It also almost looks like a trapezoid. The problem with that is these are not exactly parallel to each other. They are going to converge together eventually. Okay, so they're not exactly parallel, or it's not a parallelogram, it's not a trapezoid, it's not a kite. This is just a weird little polygon. So one thing we can do for our strategy for finding the area here is, I'm going to start by drawing a box that goes around the outside here. Okay, so this box is going to be all the way around there. So I could find the area of that blue rectangle. That one's really straightforward. The area of that is going to be base times height, which is going to be 1, 2, 3, 4, 5, 6, and then it goes up to 8. So just 6 times 8 to give me 48. Well, the area that I really want, though, is this area here. I want what's inside that figure, like that. So basically what I've created is a scenario where I have this blue rectangle that goes around the shape. And what I want to do is I want to cut off these 4 corners. That's how I can create that. So what I'm going to do is I'm just going to find those 4 triangles and find their areas. And those 4 triangles are actually really straightforward here. This is 1, 2, 3, and then this is 1, 2, 3 here. 1, 2, 3, and 2. 1, 2, 3, 4, 5, 6 on this side, and then 1, 2, 3, 4 on that side, and then 2 and 1, 2, 3, 4, 5. So I can do 4 little areas. So my 4 areas are going to be 1/2 of 3 times 3, 1/2 of 3 times 2, 1/2 of 5 times 2, and 1/2 of 4 times 6. Okay, so those are my 4 different little triangles there. So I get this, I'm going to have 4.5, 3, 5, and 12. So the overall area of my red figure is going to be the difference between this and all 4 of those. So the area is going to equal to 48 minus 4.5 plus 3 plus 5 plus 12, like that. Okay, so I'm going to do that. I got 48 minus all of those. And that comes out to 23.5 units squared. Okay, so this is for those irregular polygons, the one where we can't quite model like we can the other ones. Okay, so let's just do one more just to kind of see this last example. Find the perimeter and area of ABCD with these vertices. So we got -3, 0 is A, 3, 2 is B, C is 4, -1, D is -2, -1, 2, 3 right here. Okay. So with this, I believe I'm going to double check here. So it goes 1, 2, 1, 2, 3, 4, 5. 1, 2, 1, 2, 3, 4, 5, 6. You know what? This one's pretty much the same as that previous example. So I'm just going to leave it to you on that one. I'll set it up for you a little bit. You can figure out the rest of it. If I trace the outside, let me just make sure I got all my points in the right spot. 4, -1, -2, -3. Yeah. So if I draw it around like this, basically find the area of this blue rectangle and then cut off those 4 corners. Okay. This is just another example, just like the previous one, because it's not exactly a trapezoid and it's not exactly anything else like a kite or anything like that. So you're just simply going to do the same thing, find the area of the blue rectangle, and then cut off those other pieces there. Okay. But that is it for today. And so a quick review, most problems are going to be like this. You're going to find perimeter area using your formulas, but also using distance. Okay. One thing I forgot to mention is you can also find distances without Pythagorean theorem if instead you want to do, let's write this in green over here, distance formula. So x2 minus x1 squared plus y2 minus y1 squared. Okay. So you can choose to do that instead if you want to. Okay. So you used a distance formula. I would do that for like the FG and as well as the GH, or just the one time because it's the same length between them. All right. But that's it for today. So again, using these different formulas, just looking for how do they look like on a coordinate grid. And sometimes you might have to figure out what is the shape before you can pick which formula to use. All right. That's it for today. Take care, everyone.